Well, hello, everyone. Thank you for attending today's webinar, Solutions for the Geospatial Data Tsunami. My name is Amy, and I am the Membership Associate at the National States Geographic Information Council. If you are unfamiliar with our organization, NSGIC exists to advance the effective national coordination of geospatial information by supporting state-level cooperation. We serve as a national forum of the development of capable and future-oriented geospatial leadership. If you'd like to learn more about us, please visit our website, www.nisgic.org. Some reminders for our call today. All attendees have been muted on entrance. There will be time at the end of presentation for Q&A, so please place your questions into the chat box. They will be answered and read aloud at the end of the presentation. This will also be a recorded version of the webinar and will be made available afterwards, so please be on the lookout for that. And with that, I would like to introduce today's presenters, Jason Caldwell and Sean Benham. I will now turn it over to both of them. Jason?
All right, thanks so much, Amy, appreciate it. So happy to be able to present today to everybody. So appreciate you coming onto the call and being interested in this subject matter. As a quick introduction to myself, I've been with Sanborn since 1998. And so going on 24 years this August with Sanborn, and have seen, quite a phenomenal shift in terms of how much data we have to process on a daily basis. So it's been interesting for me to put this presentation together because it definitely gives me some reflection to what I've gone through in my career. And today with me, Sean Benham, he's been in this business for well over 20 years as well, and I think has seen that same level of shift. And it's nice to have the level of expertise that Sean brings to support me in this presentation. So appreciate that. So it's always interesting putting a presentation like this together. From our perspective, the data tsunami is a real thing, and I have some definitely interesting statistics to share as we go through this presentation. But one thing I always like reflecting on is kind of the history of what I've done in my career. And I started in '98, as I mentioned, and at that point in time, I was actually doing stereo compilation mapping work for Sanborn. And, really I had a quota at that time that they had expected every compiler to meet, which was collecting 1,400 points an hour, right? So they actually looked at that metric and wanted to make sure that, we were achieving that metric as we built the maps for our customers at that time. Well, the reason why I bring that up is because today we're working with sensors that are much more automated, that are collecting 4 million points a second. And so that's just one illustration of really what we're going to talk about today, going from 1,500 points an hour to 4 million points a second in terms of data capture methodology. And when you talk about data tsunami, we've had to deal with this. I think every vendor that's been in the mapping and GIS environment for several years really has been at the forefront of this data tsunami concept. But many of our customers are starting to kind of feel this pain as well. So I thought it was an interesting presentation to talk about. So in terms of our agenda today, I'm just going to do a quick overview of Sanborn. Then I'm going to talk about why we're seeing this data tsunami with a couple of examples. We both see it from a static perspective, which I would call the base mapping piece of it, and then also on the M2M, which is really the Internet of Things that a lot of people are talking about today. Then we'll kind of go into how we can handle all this data. I have a graphic in there that we'll call it, and I think it goes along with the metaphor of tsunami. Where are my floaties, right? So where are my support functions to help me get through all this data? We do see data democratization as the primary functionality of dealing with this issue. And then we're going to talk a little bit about Sanborn's solution. I think there's many solutions in the market today, but Sanborn provides a unique solution that we provide to our customers that is called the Geo-Data Explorer. And at that time, I'm going to hand it off to Sean, and he's going to do a live demo. And then we'll open up for questions. So feel free to throw those questions into the chat as we go through the presentation and the demo. So just as a real quick recap, I'm actually coming from Colorado Springs today. Beautiful day today, but we're supposed to get snow on Friday. So we're not quite out of the winter season yet. But Sean, I know, is in Northern Virginia, and we do have offices all across the United States. We are headquartered in Colorado Springs. However, we have multiple offices in Charlotte as well as Horn Lake and other locations like New York as well. So we're spread across the US, and as a company, because of the type of work we do have multiple different levels of licensing and professionals, everything from PhD level type of people to certifications from ASPRS, as well as the Project Management Institute, as well as Microsoft and Cisco. So a lot of expertise at the Sanborn side that really support me and Sean in terms of being able to provide presentations like this, as well as execute on the contracts that we provide to our customers themselves. I think many of you know this, but Sanborn is the oldest map company in the US. We started making maps in 1866. I think this is a great timeline to really illustrate the issue that we're going to be talking about today, which is the data tsunami. When we first started making aerial mapping data sets and imagery data sets, we were one of the first companies that created what we call the digital ortho production department. Right prior to this time, prior to 1988, what we were doing at that time was creating hard copy orthos and providing essentially plots to the end user or the client with that imagery data on it. In 1988 is when we started shifting into more of a digital environment. So it's interesting because the first client we actually delivered a digital ortho photo to was Clark County, Nevada, which is Las Vegas. And that data set was a pretty low resolution black and white data set that we provided. The methodology for actually shipping that data to the customer was in the back of a refrigerated truck on 8-track tapes, and the truck was full. So that kind of gives you an illustration of why I was saying that vendors like Sanborn have really been on the forefront of this data tsunami issue. And the fact that in 1988, we were actually starting to think about this issue and having to drive refrigerated trucks around is just an amazing concept from my perspective. So anyways, things have changed quite a bit over the years. I mean, Moore's Law is definitely in effect in terms of hardware and sensors and computers and things of that nature. So we've been able to handle the type of data that we collect, the sensors, the systems that we use have all expanded in terms of their capabilities. And so it's been a pretty exciting journey for me, but also in terms of where we're at in 2022, it's not slowing down, right? So trying to figure out how to resolve this is definitely something of interest. So one of the things I want to talk about is the concept of the geospatial value chain. When we look at it from a Sanborn perspective, we always look at it from a perspective of a pyramid. There's a data map production, which is kind of the baseline. A lot of you are familiar with what this looks like. This is your base map data. The heavier data sets that you're dealing with are probably elevation data sets and imagery data sets and things of that nature. And so it's great to have that data, but you got to be able to do something with that data. You got to be able to make it actionable. You got to be able to provide intelligence on top of that data. And so the way we see this working is that as you move up in this pyramid, you can provide a little bit more value with the final concept of being at the top or the pinnacle of the pyramid, which is called decision support. The idea here, and we're going to talk about this today, is how do you take all this data that you're getting and actually turn it into something that's actionable to allow for you to answer the business decisions that you have to make. And we're going to talk a little bit about that as we work through the presentation. But this concept is really important because it's one thing to have all this data. It's another thing to make that data actionable. And that's really what the focus is today. So what is a data tsunami? Well, I've done some research here. I was always interested in put in, data tsunami into Google and do some quick searches, and it always pops up an actual real tsunami, right? And that's not what we're talking about today. We're not talking about water. We're really talking about bits of information. What's crazy to me is, what we're seeing, and we're seeing backup from multiple reports on this, is that from 2017 to where we're going to be in 2025, the amount of data that we're going to have to deal with is exponential. And I think all of you are seeing that in your daily workloads as you're, dealing with geospatial data and non-geospatial data. What was interesting about this report is that 25% of this data in 2025 is going to be actually coming from real-time data, right? And so that's really connecting back to what we call Internet of Things and different devices that are connecting to each other. So being able to take that static data as well as the IoT data and actually combine that together into a source that allows you to create actionable information for your end users and stake users is what is very powerful. The other thing that's important to recognize is that a lot of this data isn't being stored, right? It's just live data feeds that are coming through that isn't actually being kept in terms of an archive. And so how do you take that live data and still use it from a perspective of both live as well as archival perspectives? So That concept is a little tougher because not everybody is working with live data, but I can almost guarantee that at some point in time in your careers as you move forward, likely you will be. So anyways, I mean, really what we're getting at here is the information age is reaching an inflection point, right? The data today is literally everywhere, and how we harness it is more important than ever before. And that's really the message here, right? Is how do we take all this information and do something with it? You're probably thinking, hey, yeah, that's great. We know Google, we know Twitter, all these guys, you know, Instagram, they have all these images, there's all this data out there, but how does that really affect me in the geospatial world? Well, I thought I'd kind of show you a couple of examples of what that looks like. So this is just static data. This isn't looking at the IoT type of data yet, but just looking at base map data and elevation data and imagery data. And what I tried to do here is break it down by a county level. This is an average size of the county. I know some counties are small on this and some are quite larger, as well as a state level. Again, this is the average size of the state. So there's a lot of states that are smaller than that and several that are larger than that. But in general terms, what I'm trying to show here is on the elevation side of things, most people were using the USGS NED data, especially in the West. I know a lot of states in the East had their own LiDAR programs and stuff, so they were working with data before the 3-depth quality 1 and quality 2 data sets were being procured. But just comparing the original NED data sets, the 10-meter data sets, to the USGS QL1 and QL2 data sets, you can see what we're dealing with, right? You're going from a fraction of a gigabyte to, you know, 1,600 gigabytes if you're at QL1 for a county, and 120,000 gigabytes if you're at QL1 for a state. The imagery example is similar. A lot of states were doing 12-inch ortho imagery, but we're starting to see a lot of states and counties move towards a higher resolution data sets. So 3-inch ortho imagery. The other thing that we're seeing a lot of is that people are saying, hey, we don't just want the ortho image, we also want the oblique imagery data. And so that also adds quite a bit of, you know, file space that has to be used in terms of this increase in volume. So, you know, if you want to try to put this in percentage of increase from, let's call it 10 years ago to where we're at today, if we're talking about the DEMS, this is 1,000,000% increase in data volume. If we're talking about the imagery examples and including the oblique, we're talking about over 100,000% increase in data volume. So it's real in the geospatial world, even on the static side. And we haven't even started talking about the actual real-time data. So when we start talking about the IoT, the Internet of Things, and the M2M dynamic data, the live real-time data, this is the issue that you have. In 2015, there was about 262 million devices connected for M2M. We're expecting over 21 billion in 2025. So, you know, Internet of Things is real. I mean, there's a lot of interaction with the Internet of Things or IoT with the geospatial world. What I would tell you today is that my opinion is that almost all of the IoT will have some level of geocoding or geospatial concepts attached to it, so you understand where that data is coming from spatially. And so this really allows us to be much more agile in terms of the information that we're gathering, but how do we actually empower it in such a way that is going to enable our end users and stakeholders to get the value out of it that they really need. So here's just a couple of examples that we've seen in terms of M2M in the government side of things. Traffic management is the easy one. Connected cars, I think a lot of people have heard about, you know, the thoughts of these cars being able to communicate together, or maybe emergency management vehicles can communicate to autonomous vehicles so they move out of the way, as well as traffic signals and things of that nature. Connected weather insights is another good one, and I'm going to talk about an example of that here pretty quickly in this presentation. And then connected buildings, right? Smart cities, smart buildings, all these concepts are all going to be used in IoT, and they're going to get all kinds of information data out of these sensor technologies that is eventually going to be given to the geospatial community to do something with, right? So I want to talk about one presentation that actually Sanborn provided with the state of Arkansas at the 2019 NSGIC conference in Snowbird. This was an interesting presentation because Sanborn had to support the state in doing some imagery processing on an emergency response perspective. But more importantly, what was interesting to me on this presentation, and really the project overall, is that in 2019, Arkansas already had basically an IoT component set up, right? They had live sensors that were actually documenting the weather that was happening in Oklahoma. They also had live sensors on the actual stream gauges themselves that were giving feedback to the state of Arkansas saying, hey, within the next day or within the next 2 days, you're going to see some influx of flooding due to the storm event that happened. So this is a perfect example of where live data was actually brought in to a geospatial world and the data was made actionable. So the idea of, are we really doing this today or not? From my perspective is real, right? I mean, we've seen a lot of different presentations over the years at NSGIC of people, showing examples just like this without really stating that this is IoT or M2M, but that's exactly what this is. So I thought it was good to kind of represent this and show this as an example, as this was a previous presentation that was given by myself and Shelby about the state of Arkansas and what they were dealing with here. And it was actually a presentation at NSGIC. So other example I have here is similar to what we've already talked about. In this example, we have a common operating picture that Sanborn had built for a customer that we had. And really the idea here is being able to interact with live AVL information, live CCTV camera information, which are all M2M components of the IoT, and being able to actually use that data in an actionable way where we can show zones where we don't have sites, which you can see here, for example, is you have the AVL information of vehicles that are traveling through the zone that we're actually protecting. And then we have sites of people that are overseeing those VIP assets to make sure that they have a direct line of sight for them to ensure that there's not going to be any risk to them. So in this example, this is being run as a preventative action. So looking at in where the red is being shown here, this is showing where you have areas that are in the blank space. And then as you continue moving through, you can see where it opens back up. So really the concept is we can track all this live information. We can take this information, display it in a visualization way that allows the end user to understand where the highest risk potentials are and where you can actually go in and actually correct for those blind spots that you have. In this example, again, it's more of an example for a first responder that may want to pre-plan or actually have an active command and control center that looks at the assets in live perspective. So that's just two little examples that I showed you, but I wanted to show you this Beecham Research report that I ran across that talks about IoT. And the reason I want to show you this isn't so you can dig in and read every single letter here, because I'm assuming that it's pretty hard to see every single thing there. But the point I wanted to make is that IoT is going to be everywhere within the government, right? I mean, you're going to see it on the building side, on the energy side, on the transportation side, health side of things, even in the ICT and transportation side of things. So it's not going to get smaller. The IoT and the amount of data that you're going to be receiving from the IoT is just going to continue to grow. So how do we harness this data and put it in an actionable methodology? So this gets to where are my floaties, right? And again, what I mean by floaties are, how do I deal with all this data? What is the easiest functionality to actually work through it? So data democratization, right? I think this is something that has come up within NSGIC, and I definitely feel this is an important aspect of government as we move forward. And really, it's the ongoing process of enabling everybody in the organization, regardless of their technical know-how, to feel comfortable and confident in using the data that we provide to them, right? So the one thing that I think was important to me when I was researching this and putting this presentation together is that it's not just simply about providing the data to the end user, right? You also have to get them comfortable. You have to educate them about the use of the data, what the data is, and how the data can be used for this really to function well. And so it does include multiple aspects of it. So when you think about this, what we saw is there's a lot of challenges associated with the education aspect of it. Before I get to that, I think one stat that kind of blew my mind when I was doing this research is that 40% of the time that engineers spend on a program is just trying to locate and validate the information that they're looking at or looking for. And so what we're really trying to do as a company from Sanborn's perspective, as well as empower our end users at the state level and at the government level, is trying to enable the users to reduce this 40% down to under 10% or maybe under 5%. Getting them to trust the data, getting them to understand where to find the data, making it easy for them to use the data is all a function of the solution here. So the data challenges, I don't have access to the data I need. I can't trust the data. I have access to data, but lack the skills to use the data or ask the right questions, right? So this is really talking about the educational concepts of it. the analytical tools provided are designed for experts, right? We need to create a simple enough way for them to access and use the data on the analytical side that gives them the ability to trust it. We gave a presentation similar to this to a state customer last week. And when we actually ran through the demo that we're about to run through, the customer that we were dealing with is more in a management position and not really a technical position. And he was blown away by how easy the tool was to use. And says, you know, I can answer most of my questions and it looks like it's really easy to use this tool. So I'm really excited about, you know, rolling this out. And so that really is, you know, meant something to me because that's exactly what we were looking for when we built the solution that we're about to show you. And then, you know, as we continue to look through this, you know, having an ongoing process to allow for people to get access to the data in a simple way, right? That's the principle that we're trying to achieve here. So when we looked at this challenge that we were faced with in terms of handling all this data for some of our customers, again, it was more than just the discovery piece of it, but the discovery piece from a tools perspective was very important. This really comes down to data storage. If you remember back earlier to this presentation, I talked about the idea that you know, a lot of this data can't even be stored locally because it's not, you don't have enough storage to be able to store the data. Making it easy to discover the data, making it easy to visualize the data, and then making it easy to analyze the data are all aspects of things that we looked at when we built this solution, the Geo-Data Explorer. So really what it comes down to is this Venn chart here, right? How do we provide self-service analytics, you know, easy access to the data that people can find, and then education about the data to work together to basically be able to build a solution to handle all the information that we're bringing in. So you can see here on the right, the Venn diagram, I mean, all these different things. We've built the tools, we can provide the education, we can make sure that the data is out there for people to use. And where these all overlap end up being in data-informed decisions. And this is pretty critical because this really gets back to that initial chart I showed you earlier in the presentation. Is how do we get to the pinnacle of the geospatial value chain? And so this is one of the ways, and it is going to be a needed resource, I think, for all agencies as we move forward, working with the volume of data that we're working with, both for private companies as well as for government entities. So being able to get all these three components aligned and overlapped in such a way that allows us to get to the top of this pyramid is very important. So let's talk a little bit about what we created. Sanborn created the Geo-Data Explorer tool. And the tool enabled our clients to do all kinds of different things with it. But really what it provided is cloud-based storage of the data. It allows for user credentialing, allows for data cataloging, and allows for data analysis. And then the final piece allows for download curation. These are all functions that we felt were needed. And when we talked to our customers, that's exactly what they had told us. So providing the user, you know, interface, being able to get access to search the data, then being able to analyze the data and potentially download the data is all an important concept of the tool that we created here. So we're going to go through this, and Sean's going to spend a lot more time on this, so I'm not going to spend a ton of time on the presentation side, but really the tool provides several different functionalities. The first is to find the data, right? Just trying to identify where the data is at, what metadata do you have about it, making sure it's the right data to be able to use. In this example, we're showing, you know, elevation data, and that's what you'll see, I think, for most of this presentation. But the one thing to point out is this solution doesn't just rely on elevation data. It can be any type of raster or vector type of data sets, as well as metadata that's integrated with it. And so it really allows you to search for exactly what you're looking for. And then the next step is that it allows you to preview that data. So you can actually see that data in real time as you identify where that data is at. There's different types of data sets that can be used. In this example, we're looking at DEMS, we're looking at intensity views. Then actually within the tool, you can also look at LAS files. So as an example here, you can see the actual point cloud of a specific area. Then the last thing that you can do with this data is if you feel that the analytical assessment that you can do within the actual tool itself isn't enough, and you need to bring that down and use that within a much more powerful software, like an Esri tool or something else like that, you can actually download this data, bring it to your desktop or to your servers, and then actually from there use it within what other tools you want. Important aspect to talk about here is that the data, when we put it into this tool and when it gets downloaded, is in non-proprietary formats. So it's in open data formats that lets our customers use the data they want to use it once they download it. It also typically is open, right? So you can, once you download the data, you can do what you need to do with it. So All right, so the other thing that we do provide as part of this solution is a backend dashboard. This provides some levels of administration level tools as well. So our clients can administer who they want to give access to this data. They also have the ability to interact with local OAuth administration and credentialing. You can also specify user download limits. You can look at the history of downloads. This is a pretty important one for most of our customers because they like to understand who's using the data for the next go around in terms of passing the buck in terms of the dollars. It also gives you user metrics. So you can look at different department levels and category levels in terms of use. You can look at how much is being downloaded. You can look at where that data is being downloaded. So you have an idea of where, in terms of spatially, it makes the most sense. There's a lot more you can do with the backend dashboard, but those are kind of the high levels of what's available there. So, all right. So with that said, I'm going to hand it off to Sean to do about a 15-minute demo, and then we'll have questions and answers after that. So, Sean, I'll stop sharing here. So.
Yep. Thank you, Jason. I will share out my screen. Jason, if you can just confirm that you're able to see that.
Yep, I can see it.
All right, great. So as Jason just previewed, I'm going to go into a little more in-depth here on the Geo-Data Explorer and its capabilities, and really in alignment with the challenges that Jason laid out, right, in terms of data discovery, data visualization and preview, and then data retrieval. So what we see here is the state of Michigan. The state is fortunate enough and through their program now has a statewide LiDAR program, full coverage of their statewide LiDAR, which is great. They also have are lucky enough to have multiple vintages in some cases of LiDAR data, right? So again, this kind of building data tsunami of LiDAR data over various years, over various projects. So how first do we discover where all this data is? So we have a couple different ways we can do this. So at its core, if we're just looking to say, show me all the data, say within Bay County, within the state, how would we be able to quickly see what's available? Well, we click Bay County, we load the data sets, and now we can see multiple vintages, multiple projects worth of data here, various years. And we can actually start to visualize where those data sets are, right? So the 2015 Bay County covers most of the county. We have some overlapping projects, and then we have this sort of odd-looking project from 2020 for river flooding. So let's expand that here. We can start to get some metadata on the data set, right? So we can see acquisition dates, who collected it. Sanborn was lucky enough to collect it. What sensor we were using. So that's an interesting data set, right? So let's maybe isolate in on this one. So now I see another piece here. So I'm thinking, well, maybe there's more data to this project than I'm seeing just in Bay County. So let's just search on that AOI as a whole. I hit load data set here. So now I can see that this is actually part of a larger multi-county project that was flown to support a dam burst here north of Midland in Michigan in 2020. So again, very quick way to discover which data set is within Bay County, but then also adjacent data or alternative data that might be supported, multi-county wide. There's also a few other ways we can search, right? Maybe we're not interested in a county, but maybe we're interested in townships. So we can have various search shapefiles here or databases to search from. Maybe we're interested in township and ranges. So we can search specifically on a given township and range. Maybe we're interested in watersheds, right? Maybe we're managing watershed districts here, and we can isolate and load specific data sets just by watershed. So various ways that we can very quickly visualize which data is available, which vintage, if we have multiple vintages of data within a county we want to see, and then start to isolate in on specific areas. So again, let's go back and load our flood data set here. So now we can just very quickly, and again, this is all web-based application, really no tools needed. This is very much a Google Maps type interface in terms of dragging and clicking. So let's maybe zoom in and start to take a look at some specific areas. So we have a basic street map loaded. We can also load in some satellite data if that helps us identify maybe more of a specific area of interest. So let's take a look at Midland. So here we have the satellite map behind us. We have a very simple tool where I can just sort of say, let's just take a look at this group of tiles here. Now there's a couple preview tools here that we can start to look at. So this is a bit of a deeper dive into the actual data that's available here. So this button loads the intensity rasters. So now we can get a very quick look at the intensity imagery associated with this line of data. Maybe we want to look at a bare earth DEM view, right? So now we can start to toggle between product types here that are available to start to, again, very quickly say, is this the data I'm looking for? Is this the data that's going to help me solve my problem and that I need to download? We can even start to switch some of these individuals, right? Individual tiles. So if I want to look at the DEM against the intensity, we can do that as well. As Jason pointed out, so let's maybe say, okay, we think based on the intensity of this this area, this is the tile that I need for my project, or that I have an interest in viewing. But I want to look at the point cloud in a bit more detail. So I can actually go ahead and start to preview the LAS tile. So this is going to start to load me into a 3D view here. So we can, again, no tools needed. This is all just a web-based application. We can start to take a look at the actual point cloud data and visualize what we have available in the data set. So all I'm doing here is adjusting some of the elevation range, and we start to really see in a 3D environment, separate from the previews of just the raster view, what we have available in the point cloud, right? So this is a full point cloud view with an elevation shading. We have the ability to change some of our gradient schemes to custom visualize this. I tend to like the height, the red height view here. But we also have the ability to very quickly just preview it at some different with some different views, right? So again, the intensity now in a 3D point cloud view, right? Very useful, sort of an ortho type look here at what we have on the ground, what's going on. We can also look at it from a classification standpoint, right? So this LAS data is classified to bare earth. So now we're starting to separate out ground versus non-ground points. Maybe I'll switch back to elevation here. Let's maybe zoom around. We'll try to find an interesting feature to look at. So maybe we look at this building here, right? So obviously we have a building. We have some very basic analytical tools built in here that we can really get some quick information, right? So let's say this building is of interest, and we're really just looking at how tall are we talking on this building, right? So click here, we're at about 25 feet, about a two-story building, pretty typical. Switch over here. Now let's see, well, we're interested in the area of this building, right? So now we can start to do some very basic measurements here. And we have about 17,000 square feet on the roof line here. Again, very simple tools, very simple to use, but very quick analytics, right? So maybe we've answered our question or solved our problem here without even having to download a data set, right? We've gone out, we've discovered the data, we have some very quick analytics, and we're able to move on and go about our project. Now, maybe there's a need to or an interest in downloading some of this LAS data, right? We'll go back to data retrieval on some other items here in a second, but even within this single LAS tile, maybe we have an interest just in this site. The tool actually has some capabilities now to add in a clip tool. So we can actually say, let's just worry about anything I'm going to put inside of this particular area. So we'll bring this up to ground. We'll raise this up. Now we can actually, if I zoom in here a bit, can actually start to say, okay, I can separate points by height. I can separate them by area. or I can even go underground here and move things down or move things up and start to take away individual points. And again, we can start to, just from a visualization standpoint now, only see the area of interest that we're interested in. Or maybe we want to clip that area out, right? Maybe that's a sensitive area. We're interested in giving someone the rest of that tile, but we don't want those points within it. We also have the ability to clip outside of that tool. So let's go back to inside. This is our site. We're happy with what we have. We can even slide it over. We can slide it back.
Sean, I don't know if you muted yourself, but we can't hear you. No. Sorry, everybody, give us a second while I... Sean, if you want to try to do the demo without audio, I'll try to do the audio for you. No audio on our side. Can you hear me though? So why don't you try to do the demo and I'll try to give the audio on top of you doing the demo. So, okay. So this is gonna be a little tough for me, but I'll kind of walk through it with you guys. So I think what Sean's gonna show you here is the fact that this is kind of the download of the data sets itself, right? So we can actually go in, and this is very similar to like an Amazon cart or something else like that, where you can actually download the data that you want. This is especially valuable for the power users that want to actually get access to the actual LAS files or the DEMS or some of the other data that may not be available through other methodologies. The LAS file, I think, are one of the more powerful data sets, but the point that we're showing here is that we can download this as tiles. You can download it as multiple tiles. You can also download it as a clipped file as well. So in this case, it's just going to be the clip file that's being downloaded. So as you can see there, it's processing the data set at the top there, going through a download process. And it's saved to cart. And once the information is available and ready for download, essentially you would typically receive an email that says, okay, this is the location for the information. You click on that and then you would actually get the download. I'm not sure if you saw it, but there is some metrics associated with the download. So it kind of shows you the total size of the data that's being downloaded and things of that nature. Really the point of this tool, there you go, you can see kind of the information that's available there. The point of this tool is not necessarily to allow for everybody to download the data, but it does give you the functionality to do that. To be able to view the data, to search for where the data is available, to be able to measure and do some other minor analytics on the data. In a lot of cases, will answer a lot of the questions that the end stakeholders have about the data and about the need for the data. But in some cases, downloading that LAS file definitely provides some additional value. Now we're going to kind of show you the back-end user metrics capabilities. So this is a dashboard on the back end that administrators would have access to. And there's a lot of different ways that we can set this up. A few things here on the left are the graphs that are showing kind of the types of products that are being downloaded. You can search by year, by month, by day. You can export this out to a CSV or Excel file. A few other functionalities show like what different levels of departments have downloaded the data, total counts in 22. As you can see here, showing LAS or DEMS or intensity in terms of the download capability. It is interesting. I mean, in this particular use case, the DEMS are what are being downloaded more than anything else. I think a lot of these DEMS are going to be made available through web services and different ways to access them beyond just having to download them. So the value proposition of downloading the DEMS in the long term, I think, would go down, but to be able to get access to the LAS is very valuable. On the right-hand side, Sean's kind of showing the different percentages of customers and what they've actually downloaded, the type of customer that's downloaded it. If this needed to be shown as an individual user, we could even do that. Again, we can separate this and search by all kinds of different valuations depending on what the what the need is there. The other thing that we can do in terms of the downloads is we can show where the data is being downloaded, meaning the location or the spatial location of the data set, so you can kind of get an understanding of what is most valuable to most of the customers. We have received plenty of feedback about this level of dashboard, really providing information to the primary stakeholder who essentially hosts the data and has the data for download to the secondary stakeholders to allow them to understand what stakeholders have taken advantage of this data set the most. So as they move forward into the next procurement cycle for additional data, they know who to reach out to because those individuals have used most of the data. So I think that about wraps it up. Sorry for the technical issues there. Hopefully we got through it okay. I wanted to open it up to see if there's any questions or if anybody has any comments or anything else. So sorry about that, Amy. Hopefully you can hear me still. So
yep.
Okay.
Still can hear you. So yeah, folks, if you have any questions, please feel free to pop them in the chat and I will read them aloud for Jason and Sean.
Right. Jeff, that's a great recommendation in terms of switching to the audio on the phone. I think we barely got through it. We probably should have done that in the first place. Thanks for that suggestion.
Frank asks, what is the Geo-Data? Oh, sorry, let me go back up. What is the Geo-Data Explorer built-in?
So, I mean, there's a couple different functionalities as you saw in that demo. This is a tool that essentially Sanborn software development built out. And so it's not built in another ecosystem. It's essentially a Sanborn proprietary tool at this point. We think that's the best way to do it right now because of some of the limitations that we see in the market space for some of the COTS tools that are available, especially in handling LAS files, for example. So, but we're always interested in understanding if there's other tools that can be used to essentially demonstrate the same capability. Esri is obviously a big one that we always look at to determine whether or not that one is going to be, that software is capable of handling the LAS and some of the other functionality that is here. We're an Esri partner, and so being able to build on top of Esri is always important to us. But in this case, we felt like it made more sense to build it as a standalone product. So.
Jared asked, how does data get into, oh, sorry, let me go back down. How does data get into the system? Do managers have to additional attribution on these data sets?
Right, so there's the data, how it gets into the system, I think was the first question, right? So it is essentially, I don't know if you want to call it a data lake, but basically data is archived in such a way where our system can view it. In the case of the example that we were showing here in Michigan, we had access to that data because we flew most of that data. Sanborn was the vendor to fly the LiDAR. And so we were able to easily ingest that data. Some of the functionality that will be rolled out with the version 2 will allow for managers to upload their own data into the system as well. So just depending on, you know, the egress methodology, if it's a lighter version or not as much data, it probably is easily done through the internet. But if it's a large statewide data set, for example, that's multiple petabytes of data, in a lot of cases, it's still going to be easier to kind of transfer that on traditional, you know, hard drive methodology and then upload it locally. We are cloud agnostic, so most of the solutions we are currently building are using Sanborn's private cloud, but we could use some of the public cloud as well. So depending on what your relationship is with those public cloud vendors, we can support that type of upload as well. So I think that answers the first question that he had. Do managers have additional attribution on these data sets? Yeah, I mean, so with the functionality of being able to upload your own data sets, any of the attribution that you want to have in that data set, you can add. If there's something on the front end that we're going to upload for the baseline data set that you need to have in terms of attribution and searchable capability, that's completely possible as well. So,
Sean asked, is all your temporal data stored in the same size tile scheme? Does exiting tile data need to be retiled?
So, I mean, right now it is simpler if it's stored in the same tile scheme, but we understand that multiple customers have different size of tiles, right? And so being able to work with not only data that Sanborn has created, but work with data that the client has is very important. And so, you know, it's always our goal to make sure that we can provide, you know, as flexibility as possible, the ability to provide different tiling sizes and different ways to upload the data in terms of the format itself. So I think Sean's trying to show that there is slightly different tiling schemes in his screenshot there that was actually used in this case. So.
Any other questions? Oh, Frank also asked, does it take in and let user access external web services?
Yeah, so there's pieces that can take in external web services. So we always try to build our tools so that they're compliant with OGC for web services. So if you're trying to essentially bring in a DEM that's already a WMS or WMTS or a raster product, imagery product, something of that nature. We've also done that with some base mapping products where we essentially attach or bring those in through the WMS or WMTS feed. So.
Okay, and Sean says, data architecture. You showed quick integration to a watershed-based interaction/perspective. Was that a tiled version of the data selected by the watershed boundary, or is the data also stored by watershed?
So in that particular project, I wouldn't actually call that the full watershed. That was actually a specific piece of the watershed that had a dam breach issue. And so that data set was actually categorized based upon a certain metadata format that we had. We knew the name of it basically. But as Sean just brought up here is you can actually search by watershed, right? So that's one thing that we had built into this tool. So we have the watershed there, then you can see actually what tiles of data are available by each individual watershed. So hopefully that answers the question I think that you're asking there. So.
This is Sean. Yes, it does. Maybe another way of explaining it from my understanding is what you first showed there in the earlier demonstration was actually maybe a project-based bundle of data that was to the watershed.
That's correct, right.
Okay, thank you.
Yeah, so in that example is like that, but if let's say, for example, the data was all being collected by watershed, then that would be really easy because it's project-based, but we do understand that many people want access to this based on watershed versus a county or versus a project area, right? So being able to categorize it within the watershed, which is what Sean's showing there, is important as I think you're getting at. So.
And part of the reason for my questions here is as I see it selecting tile data, I'm trying to wrap my mind around how you would manage the analytics, because a watershed is very area specific, whereas the tiles themselves are beyond the boundary. So how is that being managed in analytics?
Yeah, that's actually a good question. What I would tell you right now is that the level of analytics that are involved at the web level, meaning within this application, probably wouldn't let you do that. You'd want to download those tiles and then bring that into another solution that allows you to look at the LAS files and then clip to the boundary of the watershed to run the analytics. The fundamental analytics associated with this data set, or I'm sorry, with this software are pretty limited, right? You're doing measurements and different things like that. If you have to do some more advanced geoprocessing, it's not really that's not what the tool is built for right now. So.
Thank you.
Elliot asked, is it possible to use Explorer to access data without having to download it first? E.g., can it return a path to a file so that a VM can process the data where it sits? Also, is there an API for data discovery?
Yeah, so the first question is an easy one. The answer would be yes, right? I mean, if this, it has to do with the backend architecture in terms of where the data is stored, right? So if the data is stored, let's say on Google Cloud or Amazon Cloud, and basically you're saying, okay, I don't want to download, I just want to grab it and then do this advanced processing on it using VMs, that we can set that process up. To be honest, the initial version of this data set also enabled us to point to the client servers. So a lot of the data was actually separated all over the place at the client's location. And as a result, what we had the ability to do was to grab data and the source of the information from those different servers. This more current one here with Michigan, the data is actually stored at Sanborn server sites. The second part in terms of API, I mean, we'd have to talk to you about that. I mean, we don't open the API typically, but if there is a need in terms of further development associated with that API, in terms of what you want to get out of it, then we're happy to have that discussion. I mean, we're not closed on the idea of allowing from some additional development on top of what we already have, but it'd be more one-off case discussions. So.
And Jeff asked, what is your licensing model?
That's a great question, Jeff. So the licensing model is actually pretty open. The idea here is that it's not based upon individual user levels. I can tell you that when we start talking about cost, the volume of data does matter, but from a licensing perspective, typically we're not licensing it based upon how many users need access to it. The second thing that I'd mention is that the licensing isn't set up in such a way where it would restrict the end users, like the public, for example, to get access to the data if the state or the entity that's purchasing the license wants to give them access to it. So to be clear, we're not saying that you can just copy the executable and send it to anybody, but we're basically saying access to the data is basically unlimited based upon how the state wants to allow access to the information that's within the software. Sean, we can see your audio stuff on the screen.
All right, that was currently the last question. We still have a couple minutes at the top of the hour if anyone would like to ask any last minute questions.
All right, if anybody has additional questions beyond what was thrown in the chat, I think our contact information will be associated with the stuff that is uploaded for NSGIC. And so you can reach out directly to myself or Sean if you have questions.
Yes, we will be sending out a recording to all those who have registered, and that information will be provided as well in case there are additional questions. With that, I would like to thank Jason and Sean for their presentation today. Any last words, Jason and Sean?
No, I think, the idea here is we wanted to present, the thought process of the data volume that people are dealing with, right? We're seeing this all across the board right now. People are getting access to 3-depth data. They want to be able to provide it to their end users. And so the concept of being able to empower those end users to really take advantage of the data is really, really important. And so important that while Sanborn isn't truly just a software company, we felt obligated to be able to provide solutions to our end users where we're actually collecting and processing data for our end users. They're wanting something beyond just the delivery of the data. And so that's always our goal, is to make sure that what we provide to our customers provides, a ROI back to them that enables them to, continue working with the geospatial data that we create. So we appreciate everybody listening in, and hopefully that message came through strong. And if you have any additional questions, we're always open to to discuss both, the technology itself and or the concepts that led us to wanting to build this tool. So.
Oh, we do have one last minute question from Sean again. What size tile have you found to be most efficient for your platform?
I guess that's a tough question. I mean, right now for LiDAR data sets that are QL1 versus QL2, we tend to change that tile size up a little bit. But when we get into a platform like this, we'd like to have it consistent. So, typically, a 5,000 by 5,000 tile size is kind of a standard tile size that we've used in the past. If customers have a different preference, we're open to changing that if needed. So.
Well, once again, thank you, Jason and Sean, for your presentation and coming on today. And thank you to our audience for participating in the live webinar.
That's awesome. Thanks, Barry, and thanks, Sean and Ray. Those are nice comments. Appreciate the feedback. So.
Well, with that, I hope everyone has a great day. And thank you again to both of our presenters for today. And thank you, audience, for participating.
Thanks, Amy. Appreciate the hosting.